Okay, so what we've done so far is, starting with hydronium ion concentration, we figured out how to find pH. What's the formula for that?
pH.
pH equals
Negative
log of the hydronium ion concentration.
H3O.
Good. What we're now going to figure out is, what if instead of giving you this, what if I just gave you pH? Could you guys work backwards? Now, I guarantee you can. So watch. Guys, quiet down. If I just told you pH of 7, and then I told you it ends up being 1 in 10 million, Quinn, what would you say?
Because the pH and the exponent of like the 10 is like they're related, so they're like the same thing. So if you tell me that it's pH of 7, then I know that it's gonna be 10 to the negative 7.
Okay, Quinn.
There you go.
Quinn.
Ah,
pH equals 5.
now I know it's 10 to the negative 5th. Swag.
Yeah, swag.
That's exactly right. Okay? The formula we use for this, hydronium ion concentration equals 10 to the negative pH.
Oh.
Yes.
Wait, so different concentration of the hydronium can be different pHs?
Yeah, I mean, this is pH of 7, you know, this is pH of 4. So once again, the formula that we need to write down is concentration of H3O plus equals 10 to the negative pH power. And it works down here. If I told you pH of 4, you would say 10 to the negative 4th is my hydronium ion concentration. Okay? What about hydroxide? Concentration of OH minus equals 10 to the negative what? 10 to the negative pH? 10 to the negative pOH.
Oh.
Look, in this one it works. 10 to the negative 7th gives us this. But down here, look, pOH is 10. Concentration is 10 to the negative 10th. So concentration of OH minus equals 10 to the negative pOH power. Okay? This works easy if I give you very simple examples. But let's say now I told you I have an acid and pH equals 2.84. Get a calculator, please find me hydronium ion concentration.
So it's not gonna be. I can't do 10 to the negative 2.
That's exactly what you do. Same formula, Quinn.
It's just 10 to the negative 2.
Someone raise your hand when they get an answer? Yep.
Oh.
It's,
It is.
0.00415.
3 sig figs in your pH, 3 sig figs in your concentration.
Got it.
What if I told you, well, okay, formula is 10 to the negative pH. So in your calculator, you just do 10, and then a little arrow, and then I would suggest you do it in parentheses, do the negative pH. 10 to the negative 2.84.
I didn't do that.
What did you do?
I just did that. It worked. Maybe
Okay.
maybe it doesn't work that way.
Yeah, sure.
So when you ask questions like this, do you want us to write it as a decimal and can't just write it as 10 to the negative, whatever?
Yeah, you should, for this, write it as a negative here. Okay? Let's say, how about this? Let's merge two formulas. There's two ways you could solve this one. Try to find me hydronium ion concentration of this same thing. If the pH is 2.84, what's the hydronium ion concentration? Nope. Only if pH is 7 is pOH also 7. Or only when it's 7 are the concentrations equal.
What if it's 16?
I got something.
that is pOH. That's pOH, but that's not the concentration.
I did subtracted 10. Oh, it's 14. Right? Is that
There's two ways of going about this. I'll put it that way. Alright, let me show one way we could do it. First of all, one formula that we know is this equals 10 to the negative pOH, correct? How can we find pOH from this? Caroline?
Well, you subtract.
Brad?
You take 7, subtract 2.4 from 7, and then find whatever you take to get to that, and you add 7, you add whatever that was, I think it was 4.16, to 7, then you get 11.16.
Right.
And that's your pH.
That works. Simpler way than that, the formula we said before, pH plus pOH equals what? A number. 14. It's what you did, Caroline, but a more straightforward way. Just say pH plus pOH equals 14. So if pH equals this, pOH must equal, what's that going to be, 11.16?
14 minus that number.
Yeah.
10 to the negative 11.16 gives you my answer. Did you get it?
6.92 times 10 to the negative 12.
Sounds about right. Another way you could have gone about this. This equals H3O plus. What did I always say? The concentration of H3O plus times the concentration of OH minus always equals the same number. What is that number?
Oh. Always. 1.0 times 10 to the negative 14.
Exactly. This, concentration of H3O times concentration of OH always equals 1 times 10 to the negative 14th. So you could have just said 10 to the negative 14th divided by 0.00145. Could someone just test that real quick for me? You should get the same answer. You should get this. Good. Two ways of going about it.
Yeah.
Yep.
Okay.